Port Harcourt Section Petroleum Engineering Industry Experience Bootcamp, from subsurface to strategy. So this Experience Bootcamp is hosted by the Society of Petroleum Engineers Section 103, Port Harcourt Section, in collaboration with Cypher Crescent Limited. And as you are aware, we've been carrying out the various subsurface disciplines from the geology and geoscience, which was done in the first week, to the petrophysics, which was concluded last week. And then this week is the third week. We will be having our reservoir engineering discipline, the learning track. My name is Samuel Nathaniel, and I'm a petroleum engineer in Cypher Crescent Limited. I work in the reservoir engineering team, and I'll be your moderator for today. So our speaker today is Mr. Victor Olatope, who is a reservoir engineer at Renaissance Africa Energy Company Limited. Mr. Victor is a reservoir engineer at Renaissance here with over 15 years of experience. He is dedicated to maximizing reservoir performance and recovery efficiency through data-driven strategies. Outside of work, he enjoys playing football and table tennis. So we have someone who is very experienced leading this session today. If your virtual hands are not very busy, please let's have a round of applause coming in for him as he gets ready to begin the session. Thank you, thank you. Let's keep the emojis coming in. Okay, Mr. Victor, the floor is yours. Please go ahead with your presentation. Thank you.
All right, good afternoon, everyone. Can you hear me?
Yes, I can hear you clearly, sir.
All right, good afternoon, everyone. Glad to be part of this Connect. Let me share my screen. I would have loved to prepare slides for this, but I kind of prefer maybe writing sometimes. So maybe there's a part of me that's still a lecturer, but I prefer writing on the board. So let me share my screen. If that's okay. And please feel free to ask any question. Whatever you may want to, ask, please feel free to ask, and let's have a good discussion.
Okay. Simeon, could you make Mr. Victor co-host? Okay, thank you. Mr. Victor, you can go ahead and share your screen, sir.
Okay. Now 1 minute. 1 minute. Let me know if you can see my screen.
Yes, I can see your screen, sir.
Okay. Okay. So good afternoon, everyone. I think this stuff is a really great opportunity to, learn firsthand some of the things that we do in the industry. It's good to have the school knowledge, but it's also always good to have firsthand of, what is obtainable in the field. What is obtainable in the field. And I believe that's the intent of the organizer of this program. That being said, I think it's a very good opportunity for you. When I saw the note about this, I was just looking back, and I wish that some of these things we had the opportunity of learning them while going through school and preparing for life after school. I think it's a really good idea, and also commend the organizers for coming up with this program. I've been asked to talk about reservoir engineering, and also there was also a context around acquiring download data from BHP data and the different types. So we're going to touch on them, but I think first of all, I would just like to give some overview about reservoir engineering generally, what it's about, and before we delve into the specifics of those different aspects of it, because looking at the whole oil industry, yes, reservoir engineering is mainly subsurface, but there's you cannot play a role in the different phases of activities, so it is also good to bear that in mind. All right. So that being said, so reservoir engineering role can be viewed by three key pillars. Three key pillars define what reservoir engineering is. Three key pillars. Number one is understanding what you have in place. Understanding what you have in place. Understanding what you have in place. In place. That's number one. And I'll explain each of the number two. Understanding how much you can recover from what you have in place. Number three is understanding the rates, at which you can produce what you can recover. Now, I would like one or two persons to just tell me if they understand what I've just typed, these three bullet points. Or maybe somebody just say one or two things about what they understand by what I've typed now. First of all, can you see my screen properly?
Yes, I can see your screen, sir.
Okay.
If you want to speak, please just raise your hand and you'll be given the opportunity to, or you can leave a message in the chat box. So if you have questions, you can also leave them in the chat box and then we'll take them after the presentation. Thank you.
Okay. Yeah, I think for me, this is the art of what reservoir engineering is about. So before we go on, I just want to be sure that we are with me on this one first before we proceed. Or maybe if you have any question. Yeah, sorry, I saw somebody raise his hand up just now. Yeah.
Okay.
Uzeme
We
Feta.
have a reaction. Yes. Please go ahead.
Yeah, go ahead with your question.
I do not have a question. I just want to answer this question based on what we've done.
Hey, the line is breaking a lot.
I'm going to answer that one. Can you hear me clearly?
Yeah, I can hear you now. I think it's better now.
Okay. Okay. I said I don't have a question. I just want to talk about what the rules on the screen is about understanding like it has. Like you can share one or two about what the rules on the screen.
Sorry, I didn't really hear what. Did you get the question? Hello, did you get the question?
Can you hear me now?
Yeah, I can hear you, but the line was breaking at some point.
Yeah, I said it's not a question. I just want to talk about what rules on the board based on what you said. Like we can talk something about what the rules on the screen. I just wanted to share my own 2 cents about it.
Okay. Yeah, go ahead.
Yeah. So for the first one, you said understanding what we have in place. Basically, it's just us understanding, okay, how much oil do we have initially in place, like our OIIP. That's when we have to use calculations like our material balance and volumetric analysis to understand, okay, how much of this oil or gas do we have in our reservoir. Then understand what is number two, when you said understanding how much you can recover from what we have. Because you cannot recover everything. Like sometimes recover 100% of the carbon in the reservoir. So we want to try to understand, okay, out of this 100%, how many percent can we recover from it based on the recovery mechanism we have, based on the primary driving mechanism, based on the um, secondary and tertiary, just like how much of this percentage can we effectively recover from our reservoir. Then for the third one, understanding the rate at which you can produce what you can recover. So one thing about production is that we want to produce optimally. We don't want to produce in such a way that will kill our well on time. We don't want to produce in such a way that will reduce our reservoir pressure on time. So we want to produce in such a way that we can extend the life of our reservoir. So based on one understanding, just understand, okay, at what rate should we be producing? Should we be producing high? Should we be producing low? Should we be producing like mid, moderate? Just based on that, and that's like what I can say about what you wrote on the screen. Thank you.
Yeah, thank you very much. Very good point. And I also see some people drop messages on the chat, which are also which also ties to what Uzefit has said. So for me, if we're able to get these 3 points clearly, right, our job today is done. Our job today is settled. Now, everything that we're going to, any other thing you want to discuss, like maybe whether you want to discuss pressures or PVT or simulation or whatever you want to discuss, you can always trace it back to these 3 things. And if you're able to trace it back to these 3 things, then you are good. Now, so that is good, and I'm happy that we are all on the same page on that. And I see Marvelous say the first one is in place. Yes, of course. If you look at the equation for calculating in place, you see that there's something in that equation that the RE provides, right? You have the PVT as part of it. Yes, so the RE is part of that. Then when you come to recoverable, what you can recover, then recovery factor comes in, as you have said. But also before recovery factor is also using a model to tell you, to estimate that, right? Recovery factor, you can, so there are several ways you can use to estimate that. So, so 1 second. So when you talk about this, you talk about the ACIIP. So let's not say, oh, I see somebody said original oil, OHIP. I don't know. I've not seen that one before. But it's just, let's use ACIP, hydrocarbon initially in place. So that kind of covers oil and gas and condensate and whatever you have. Then when you come here, is using models or analogs to estimate, or analogs to estimate your volume. Sorry, 1 second. Using models or analog. Use model, then this one is where is, you know, I saw somebody mention IPR. So this is where your IPR comes in. Yeah. And VLP versus VLP and all the likes. Of course, then this is where your tubing and all the things come in, how the rate at which tubing, IPR, all the likes, this is where they come in, the last one. So the main point is that you see that in every of these phases, the RE comes into play in determining what number we put for these different phases, right? The other thing we also need to think about is also to understand the RE is like an integrator. Is also to understand the RE as an integrator. Yeah. So the PG gives the RE data. Of course, is not always like a one-way traffic kind of communication, right? So you have the PP. I think for me, sorry, I'm using short abbreviations. Do we understand what? So REs, when I say REs, reservoir engineer, PG is the production geologist, PP is the petrophysics. What's the last one? You have the PT as well. These are production technologies. These are the people that deal with the wellbore. Sorry, if there's anyone you don't understand, please let me know. I see somebody type P. Yeah, I will explain to it. Sorry, I'm using shell terms. Production tech. This is petrophysics. This is production geologist. Now it's good that somebody Kimberly mentioned petroleum engineering. So all of this is what we kind of group as petroleum engineering, right? All of this is what we group as petroleum engineering. What's this? So this is the petroleum engineering. Yeah. This is the P envelope. So, I mean, generally we kind of also look at, yeah, it depends on the company though, but for me, and these are the cores of, so you also have the PGPS, production seismologist, production geologist, production seismologist. Now, in some companies, they kind of hire petroleum engineers because they want them to be able to, I mean, they just get you to be able to do everything, right? And for me, it's also good to focus that way. So as you are developing yourselves, ensure that you're able to learn from other disciplines. I don't know if Nathaniel, if this program covers other disciplines. So ensure that you're able to cover what other disciplines are doing and you understand what they do. The reservoir engineer, the advantage of a reservoir engineer is that he's able to interact with all of these people, right? At the lifetime of a reservoir engineer, you will always interact with all of these people. So you kind of know what each person does. You know what the PG does, you know what the PP does, you know what the PT does, right? So you sit at the center, you get all this info, you interact with them, so you have a fair idea of what each and every person does. So which kind of puts you in a better position to be able to have conversations about everything that they do. So my advice is that even as you go through this program, please, I encourage you to make sure you try to know what each person does. Whether it's the PG, whether it's the PS, whether it's the petrophysics, whether it's the production technologies, try to understand what they do. Because a lot of companies are moving away from having just one discipline. And the advantage of you knowing all those other disciplines is that it puts in a very, very good position to be able to have conversation in all those regards. I don't know if that makes sense to us. So don't be, I'm a reservoir engineer, this is my focus. No, I'm a production technologist, this is all I know, and this is all I'm interested in. No. Whatever you can learn from each of those disciplines, please, I encourage you to do so as much as possible. All right. So that said, so for us to achieve a lot of the things that we've mentioned earlier on, so from the first point around the in-place volume, of course, when we want to estimate the in-place volume, our first port of call is the PG. So the PG do their seismic interpretation, come up with the structures, get data from other disciplines to populate so they have the structure, right? So I'm sure we are all familiar with the structure, right? So they have the structure. So that structure, just imagine the structure like a house. Yeah. Inside that house, you have your bed, you have your you have all sorts of things inside, right? So they want to tell you, oh, how much is this house worth? You'll be saying, oh, this house is worth so much. Why? Because it contains this, it contains that, it contains this. So the same thing is with the subsurface. You have the structure, you are able to estimate what the structure contains, maybe at subsurface condition. Then you also are able to estimate it at surface condition. Now, when people do this, we have tools like Petrel. We have some Petrel. We have Petrel. We have the Petrel is the one that is popular, right? Of course, the Petrel in Petrel we kind of estimate what the in place volume is and all those things. But again, the companies are moving away from. So if you see, I don't know how many of you have seen Petrel. Those days when we were in Uniport, they kind of gave us Petrel license to be using to be tested. Unfortunately, a lot of us were just so distracted by. I can't remember. I'm not even sure I ran that thing once. So you see the PG. This is a PG. PG will do something. RE will do something to estimate the in place. So most times before the RE before the RE goes on to do his work, he has to check for consistency between these two guys. So he has to check that the numbers between the two of them are the same. So maybe like 5% variance, right? Or it depends on the company. Some companies are open to having more variance. So they check the variance between the in place from the PG and the RE if they are the same. So if they have this, if they are able to achieve this, then they progress with their work. I don't know if that makes sense. So we have Petrel, for the PGs. No, sorry. In Petrel, so if the PG finish building the static model and all those things, so the RE can pick it up from there and just continue working, basically. So a lot of the companies are moving away from, there's this, they are trying to create an integrated platform where these different disciplines can come to work in one place, right? So, for example, before Shell left, they had the PetroSign Flow. I don't know if some of you may have heard about it. They had the PetroSign Flow. The target of that PetroSign Flow is to create a platform that once the PG finishes his work or the PP finishes his work, the RE can pick it from there and just continue working without trying to move data around. And the essence of that is so that there will be no loss of information along the way. The industry has moved a lot from what it has started out with to what it is today. Before those days, when the PG finishes the static model, you have to export it. The RE now picks it to do some things on it. You're not sure if the RE is picking the right model or maybe something has happened. So they now start checking back, what is my percentage variance between what you estimated and what I estimated to see if it's aligned. So Petrel kind of allows you to have these disciplines to work in the same platform without moving out. So which helps to maintain data fidelity, which is very key. So that's on one layer. So once this is done, then you now estimate the UR. The UR, that's ultimate recovery, which is the second. So this is the first step that we talked about. Then the second step is the ultimate recovery. That's the UR or the RF. So this is where your RF comes in. So this is where you, depending on what you want to do, whether you want to use decline curve, DCA, whether you want to use volumetrics. So in this case, you need analog to work with. In this case, you need analog to work with. Then other you want to use simulators. So you have all sorts of simulators, whether you want to use decline curve analysis, DCAs, you have all sorts of tools for do that. Some cases you want to use what do they call this tool now? 0D models. 0D models. So that's the likes of so more like analytical sort of. So that's the likes of MBAL and co. MBAL, I'm not sure. I don't know if there's another tool like that. I think there is, but I can't remember the name. So that's where MBAL comes into play. Yeah. So this one analog, you use analog for this. So you see some I don't know how many of you play. Well, I hope you do. I hope nobody plays this. All this bet Nigeria and co. You know, some people those days when I was small, when I see some of these people that play all those things, you know, say this match he was drawing this social time. His draw. They played draw this year. They played draw this year. That means they will play draw this other time. So what they are trying to do essentially is to use historical data to make a judgment about what they do. Now, the same thing applies to volumetrics. Volumetric, you now said, oh, I've seen a reservoir in this area that it looks like this one. Okay, so if this one performed like this, then I believe this one will perform like this. So you just carry the recovery factor from that analog and just slam it on your reservoir and just get something out. Simulator is you use simulator to, so these are like 3D models. 3D models. You use simulator to estimate your work. You use simulator to do your work. Yeah. 3D models. More like building a 3D model, then run that on the distance. Then in some cases, you use DCAs. DCAs is usually best for field that is fully matured. Field that has been producing for some time that you have production data to use to estimate. So for new reservoirs, it may not be that useful. But you can't rule it. You may not rule it out because some people can say, okay, just do something, right? So you can still use DCAs in some cases. Then you have the last one is 0D models. When you have like MBAL, maybe you have this, you can use these Berkeley-Leverett models to estimate like recovery factors, just to get yourself going. Yeah. The whole idea is that you just have to be able to do something, right? And the essence of that, and what really makes somebody a good RE is not about the model itself, right? It's about being able to make concrete analysis, logical, sensible, step-by-step analysis of what you're doing, why you're doing what you're doing, and being able to explain it to somebody. That's what makes you stand out. So at the end of the day, you can use this MBAL to say, okay, this is what you're going with. Why? Then you're able to make your position clear that this is why I'm doing what I'm doing and all those things. Now, there's one other part that that just came to my mind that I've not mentioned in this place. I mean, you guys are new generation. I mean, you guys are, I don't know if it's Gen Z they call it. But I mean you are in the era of AI and stuff. So there's a new wave of modeling that is going on right now. I don't know if you've heard about it or not, but it's something for you to keep in mind, and it's also something to challenge you guys as something you can think about. I don't know if you've heard about surrogate models. I don't know if any of you have heard about surrogate models. So the idea of these surrogate models, and again, people are doing a lot of stuff trying to see use AI in a lot of this stuff that we're talking about. And the idea is because we have tons of data for many of our fields, right? We have tons of data. How can we use those data to be able to build a system whereby we don't need to be building models every time, right? We don't need to build models every time. And the truth is, there's no new reservoir that you can pull out that their behavior will not fit into something that you have seen in the past, right? That's the mental model, which for me, there's a high chance that that is the case, right? So you see a lot of people going into the use of surrogate models, that can we build something that can quickly estimate this for us without using simulation models? So that's a direction that a lot of people are already doing a lot of research into, and I hope you guys are open to it as well. Maybe something you can also consider as well. Yeah. So that's it about recovery factor. Then the last step is, of course, for me, all the things we've discussed here still applies there. Rate of production. Rate of production. So all the things we've discussed in these previous steps, the same model applies in this place. The same model applies in this place, because while you are doing the modeling, you also, one other thing you also play with is the rates, right? You are testing out different rate based on what you know, based on what you have. You are testing different things out. So that's so basically you can just use the same thing for, you can just take the same thing for this other one. Yeah. Now, one other thing you also, so what I've kind of given you now is like the main core of reservoir engineering, the what I would call like the framework of it. Now, every other thing that you see is always tied to trying to answer some of the questions that we've discussed about. So I know somebody mentioned focusing on SGs and which other one? That time I don't know if you were the one. Maybe talk about SGs and the pressures that we acquire. Now, why do we acquire pressure? Those of you that are familiar with Darcy equation, right? So the thing we focus on is KH what? PI minus P divided by what? BO mu, Abi? Am I correct? What am I missing? What is missing here? It's on height, pH, that. Anyway, so okay, let's say it's proportional. Let's say it's proportional. So we can take this guy out, take this guy out. So okay, let me just do something. All right, so let's say K is proportional to what? PI minus PO, right? Right? Now, if I'm measuring pressures, SGs, all I'm trying to do is to determine these numbers, right? Are we together? Oh, sorry, I know. Okay, you guys are on mute, so you're not. Sorry, pardon me. So if I'm measuring SGs, what am I trying to do? Is to determine these numbers, whether it's initial. Of course, when it's initial, what is that? Is that I'm measuring it at initial condition, Abi. Right? Then if it's so let's just see, well, let's say KH, I know it's KH, then this PI minus P divided by what? Mu. What else? What else goes into this? What else going into this? Let's say BU is here, right? Okay, the BU is probably to take it to. Oh wow, I don't even forget this thing. All right, let's just assume this is the Darcy equation. I know it's probably not correct. I'm missing something. I can't remember. I don't know what I'm missing. But let's just assume this is the thing. Now, if I run, and of course we have different viscosity times length. So let's say length is here. So okay, viscosity length. BU, I think BU is somewhere here too as well. Now, if I'm measuring pressures, taking SGs, taking whatever permanent dowel gauges, all I'm trying to do is to determine this number. Yeah, somebody just posted it. Thanks. If I'm measuring pressures, all I'm trying to do is to determine these guys, right? Is to determine this guy. SG survey. Of course, we do have instances where we do all those things together. So this is what I'm trying to determine. Right? What else? What other tests do we do? If I'm doing what they call it? Which other one? Oh, if I'm doing like full BHPs, like the one that you allow the flow to go into transient. I mean, you shorten the well, allow the flow to go into transient, and then to the point where you start feeling the boundary effects. You know, in those instances, this is what we're trying to determine, right? What they call it? We have SG, FGs, BU, build up, pressure build up. Sorry, it's pressure build up. I mean, we do have drawdown too as well, but usually we run the pressure build up survey to get this one. Yeah. Which other one? If I measure PVT from my sample, what am I trying to do? I'm trying to determine this guy and this guy, right? These are PVT samples, right? Which other thing? This one is probably what do you call it? So this one usually from logs. So this is usually from logs. Logs. So you see that whatever data I'm acquiring is tied back to the fundamental question that we're trying to answer, right? So for me, that's the way to think about what we are dealing with. So it's good to acquire data, but why are you acquiring the data? What does it fit into the whole equation or into the whole thing that we are trying to model? So that's for me, that's the mental picture you need to always have. So when we go to do SGs, SG is basically the whole idea of SG is basically, so let me 1 second. The whole idea of SG is basically sorry, let me 1 second, guys. I'll share my screen back just now. All right. Let me know. Can you see it again? Hello? Can anybody see my screen?
Yes, your screen is up, sir.
Okay. So the whole idea of SG is you have your well. Let's say this is your reservoir. You perforate the well here somewhere. You have your tubing. Let's say this is my tubing, and you put an XN nipple here somewhere. So in each of the well, they always have this holds the well from, so you can't go beyond that point unless maybe you have a tool that is smaller that can go into it. So this is your well, this is your perforation, this is your reservoir, right? Your flow comes into this place. Now the idea of SG is that you get a gauge, a pressure gauge, to acquire data first at this point, at this XN nipple. Usually you don't, usually we kind of like maybe 5 feet away from the XN nipple. Maybe you do like 5 feet away. But you have this XN nipple. They call it XN nipple. XN nipple. Of course, different wells have different configurations. So, but there's always that point where tools cannot go past, unless you have very serious issue that you want to go past. So, but they always have this XN nipple. Then, so your gauge, your pressure gauge, so they have different gauges. Your pressure gauge will be lower to this point. Of course, depending on whatever you want to do, there are different kind of tests we always do, but let's just focus on the SG for now. So the SG is that static gradient. What does static mean? The well is not flowing. So you are doing it at the time where the well is not flowing. And the idea is that you allow the reservoir to settle. So usually, depending on the quality of the reservoir, if the permeability is very good, so within a short time, the reservoir can settle or not. So you allow the reservoir to settle down after you shut it in for production. So by the time you open it again, then the whole system is normal. Normal. So there's no disturbance in the system. So you're able to take the pressure, and you assume that pressure you take is representative of the entire system. So, and that's probably another thing we need to bear in mind. There's a lot of assumptions in reservoir engineering just to make life easy for ourselves. Now, so you lower the gauge to this point, you lower the gauge to this point, this XN nipple. So this is your first stop. So most times when you see SG proposals, they have like stops. So this is the first stops. This is the first stop. Then like that's the close to the XN nipple, close to maybe like 5 feet or 2 feet, depending on whatever you choose. But me, I always recommend people staying like 5 feet away, right? Just in case, so that maybe your tool, so that it doesn't go and get stuck and hang to the XN nipple. You guys probably know that a lot of our wells are old, so they may have some issues in there. So, but usually just hang off a bit, some distance. Then after that, you take a pressure. So this is where you stop for, like maybe stop for some time, maybe like 10 minutes, 15 minutes, depending on what you're comfortable with. You stop for 10 minutes or 15 minutes. Then after you take this one, you move to the next one, you take another stop. So usually the first few steps are very close, right? Maybe like you do like 50 feet, depend on the length of the well. You can do like 50 feet or maybe 30 feet. The idea is that because it's critical for you to know what kind of fluid that is there. It's critical for you to know what kind of fluid that is there. Because when you know what kind of fluid is there, then you're able to project into the reservoir. The idea of SG is just balancing pressure. For those of you that used to do, maybe I don't know how many of you have tried putting fuel into the tank. That using all this when you use hose and all those things, the idea what you are trying to do essentially is play with pressure, right? So this is my reservoir. Maybe I have a datum depth somewhere here. This is the datum depth. Datum depth is like a reference depth for all your pressure measurement in the reservoir. So you can choose whichever one you want to work with, right? You can calculate a datum. I don't know if well, I just hope you've been taught how to calculate that, but even though there's a mathematics around it, but most times you can just pick something that that works for you, that will not give you problem in the future. I don't know I don't know the scope of what I'm supposed to cover here, but there's a datum depth. The datum depth is like a reference depth for your measurement, so that you are referencing this depth for all the pressures you are measuring in that reservoir. So it's more like a marker, not like some of when you buy a land and you say, oh, the stone. I don't know what they call that stone. That stone that they put. So that stone is like a mark for your land, right? The same thing applies to the reservoir. So you have a datum depth that you reference for all your pressure measurements. Now, so you are now taking. So when you take the pressure from this XN nipple, let me see. I think it's better I draw it inside here. So you have your datum depth. So let's say this is my datum. Let's say my datum depth is somewhere here. Sorry. Datum depth. Datum depth. You have your datum depth somewhere there. And maybe your gauge is this is where your XN nipple. So this is where your gauge is. This is where your gauge is. This is your gauge depth. Now, so that is the two depths that is critical. Of course, you also have your perforation. Now, the whole thing you are doing is that there's the assumption behind SG is that you know that the pressure at this perforation, the pressure at this perforation will be the same between the well bore and the reservoir. The pressure at a particular depth is the same. Are we together? Bernoulli principles. The pressure at this depth is the same, right? So when you correct from this datum, from this XN nipple to the perforation, then from this, you know that you are more or less saying that the pressure that I corrected to this point is the same as from this point to my datum. Sorry, the pressure that I correct to this point between the wellbore and the reservoir, they are the same, right? Then when I know this pressure, then I can now correct to the datum in the reservoir. That's the whole idea of SGs, right? But to achieve that, then that's where they now do all this acquire pressure at different stops. So that's those stops. Maybe you wait for 5 minutes. So these are all stops. You wait for 5 minutes. You wait for 10 minutes, depending on. Usually, I do 10 minutes, depending on what your experience is about your asset. Now, the idea is that you are now using those points to create like a gradient, a line of gradient. So you have measured the pressures at different points. Then you now come and have like, let's say you have something like this, right? You have maybe, if it's a reservoir that has oil and gas, oil, gas, and water, then you have a line for gas. So you have a line for gas. You have a line for oil. You have a line for water. Yeah. So you kind of have these lines that shows, so this is the depth. Yeah. Then this is the pressure. Yeah. So you have so those stops that you took can now give you something like this, right? Now, and from there, you know what is in the tubing. Now, if I'm going to project into, so you from this now, you can calculate an equation of a line. I mean, you calculate an equation of a line. From that equation, you know, you will get something like this, YMX plus C, right? Are we together? Now, what you are trying to get is this guy, this gradient. That is what you are trying to get. I don't know if I've lost or Zabi, if you are still with me. We get the stops from the SGs. Your gauge comes into the well, you get all the pressure data. Then from that pressure data, you plot it on depth versus pressure line, or pressure versus depth line. Then when you plot it, you will see lines. You're able to see, oh, maybe some point are following a certain pattern, some point are following a certain pattern. Then each of the points that are following a certain pattern, you group them together, calculate the gradient for them. I don't know if that makes sense. Calculate the gradient, calculate a line, equation of a line for them. Then from there, you can now get the gradient that you want. Yeah. So from that gradient, that will now tell you. So if this gradient give me a gradient of 0.3, if this M now give me a gradient of 0.3, what does that tell me? Who can help us? What does that tell me if it's 0.3? Or if it's between like 0.3 or 0.2 something to 0.3, let's say 37. So what does this tell me? This is PSI per foot. This is PSI per feet. What does that tell me? Who wants to help? Nobody.
The people are dropping.
Yes, Mr. Victor, we have
comments.
some comment in the
Oh,
chat.
okay. Sorry, I've not seen the chat. So sorry. Pardon me. Okay, good. Fantastic. So it's telling you that it's oil. Then if it's 0.43 or 4 something, if it's any 42 to 0.4 something, what does that still tell us? Fantastic. Now, yeah, fantastic. I think we are good. So once you start seeing those kind of numbers, it tells you the kind of fluid that you have at between what depth and what depth. Now, even though we use this to so of course when we do this, then you can now use the one that is closest to the perforation. So if we use this example now, the example we are dealing with now, this is water. So is this water now that you now extrapolate to the top to the perforation, and from the perforation into the well bore? Sorry, you extend this from the gauge depth to the perforation, and from the perforation into the reservoir, right? When you want to calculate the reservoir pressure, you're not going to use the whatever. You're not going to use the any other thing, because this is the closest one to the well perforation. So is this based on this that you now extend into the reservoir and continue? Now, another reason why this is important is why we do this is because it also gives you a sense of how the gradient in the reservoir has changed over time from what you had initially. Now, let's say you took PVT sample from this reservoir. When you did that PVT sample, it gave you a gradient. And as time goes on, you expect those numbers to change because the pressure and temperature changed. So when you do that, you can also go and check with what the PVT measured if things went according to what the PVT model said or not. I don't know if that makes sense. So that's why it's really important for always think about what value does this data bring. Now, we've talked about SG. The other one that we talk about is BU. BU is when you do all those honors plot and stuff. Let me see if I still remember. You do all those honors plot, those pressure derivative things where you now try to use this to, of course. So now, in most times, what we try to do is that when you're going into the well, you try to do flowing gradients when you go into the well. And the reason is to save time, right? Because now, if I'm going to do an SG, let's say I'm going to do an SG, right? I have to shorten the well, leave it for some time, lower the gauge into the well, and pull it out again, right? Now, so to optimize time, people kind of think about it, okay, why not I lower the gauge into the well when it's flowing? So once I get to the gauge depth, I shorten the well, then during that shortening period is when you do build up, right? During the shortening period is when you do build up. So after you finish the build up, then you now do SG. So because you are going to pull out of wood, the point is the gauge has to go into the well, has to come out. So why not just optimize the whole thing so that we can acquire all this data at once? So that's why sometimes you see that companies just prefer to do SG, BU, and SG at the same time. Like, because they know that the gauge has to move through all these things at once. But also, you have to bear in mind that there is money implication to it. So even if the well is flowing and the gauge will move, it doesn't mean that the owner of the gauge will do it for you for free. So depending on what condition or what data you need, that will determine the kind of data you want to acquire. I don't know if that makes sense. That will determine the kind of data you want to acquire. And there is the basis for some of these things. Now, this one is statutory in the sense that government require us to always acquire reservoir pressure. So we have to always go for this. But you see, these other guys, they are not always common, right? Now, the way we justify it is, and that's why most times is we do like well and reservoir reviews and to try and see what is going on. So if from your review, you see that the well is maybe has a damage or something, then you now recommend that this pressure be acquired for it. This data be acquired, this pressure build-up, flowing gradient should be acquired. So there's always a justification for whatever you want to do. And everything starts from the well and reservoir reviews. Sorry, I'm not writing this well. I don't know if that makes sense, because that is the art of everything that determines what happens, right? Whether you want to come up with an STOG, you have to review the well, you have to review your reservoir, you have to understand what is going on. you have to understand what is going on. Yeah. So I'll stop here and take questions. I don't know if I'm able to cover the scope of what is required of me. And if not, Nathaniel, please let me know. If you have any questions, also let me know. So what I've tried to do is to give you the what I would say the foundation of what reservoir engineer does, and that starts from the first 3 bullet points that we mentioned, and the role of the different disciplines in this. Now, some of the things that we do in terms of estimating in place, ultimate recovery factor that we estimate using different methods, volumetric simulators, analytical model, rate of production, and also the data that we acquire. So in this instance, I've talked about SG and pressure buildup and all those things. So, but it's not limited to this, right? Everything is about why do you need this data, right? Why do you need this data? So, for example, sometimes we go acquire CO logs. CO log is for contact to monitor contact. So maybe your reservoir has produced, you want to know where the contact is now, just to know what is going on in that reservoir. So you also do acquire that, but of course that is not in our purview. It's usually in the petrophysics purview. But whatever data that anybody acquires, the reservoir engineer sit at the heart. You see this thing? The reservoir engineer sit at the heart of all the data. So whether it's the one that he acquired himself, the one that the PP acquires, the one that the PT acquires, the one that the PG acquires, everything will still come down to him. And I also recommended that while this program is going on, make best use of what all the disciplines do. Because you might find yourself in a role where you are expected to know everything. Well, not like it's possible for you to know everything, but you're expected to know multiple things, right? And that puts you in a very good position to have very good conversations. So I'll stop here and welcome any questions, contributions, as the case may be.
Okay, thank you very much, Mr. Victor, for that presentation. It was very detailed. And this, I must say, it covers the core of what we'll be doing this week in the boot camp. For instance, the bottom hole pressure survey covering the flowing gradient, build-up, and static gradient. It forms the core of the activities which the participants will be carrying out this week. And of course, the PVT experiment, understanding the relationship between those variables and pressure. Okay. Also, I have to herald what you mentioned about the integrated review. For instance, at the start of the presentation, I mentioned that in the first week we went through the petroleum geology, the G&G. The second week we did the petrophysics, and this week is the reservoir engineering week. So we are going through the various subsurface disciplines. So that is the essence of this boot camp, to get the participants abreast with what goes on in the various disciplines, so that you are not just a reservoir engineer who knows just what you are meant to do. Rather, you have an understanding of what the geologist does, because you have to compare your in-place volumes with what the geologist gets. You have to know what the petrophysicist is doing, so that you are able to communicate with that team during an integrated review. Thank you very much, Mr. Victor, for that presentation. Okay, so we are still waiting for questions or comments if we have any.
Yeah, thanks a lot. So please feel free to ask any question. Please, I encourage you to ask questions, please. Feel free to do so. And the other thing I also want to mention is why these reservoir reviews are very key. It's because they determine a lot of stuff, right? Now, for example, when you see companies say, oh, they added a lot of volume from their short-term oil generation, it's from this place, right? They come up with new opportunities to drill new wells, is from this place. What else? They realize optimization opportunities is from this place. So, like even all this even all this data acquisition that we come up with is also determined from here. For example, if I see a well, how do I know that the well is damaged? And that's why it's always good to understand what is happening in your reservoir. So if I see a well now that maybe reservoir pressure is the same, the reservoir pressure is staying the same, but you see the bin size is about the same. Let's say the bin size is the same, but you see the gross doing like this. You see the gross doing that. Now note the reservoir pressure is the same. The bin is the same. The gross is going down. What does that kind of brings to your mind? It tells you that probably something is damaged in this reservoir, right? Maybe there's a damage. Now, if reservoir pressure was going down, and as the gross is going down, you can now say, yeah, maybe the reservoir is losing energy, right? The reservoir is losing energy. That's why the gross is going down. So it's straightforward. But when you now see a reservoir where the pressure is the same, the pressure has not declined, but the gross is going down on the same bin, it tells you start thinking in your mind that look, maybe there's a damage around this well. So what do I need to do? I now need to go and acquire this guy. So in this guy, I'm able to estimate my K, right? I'm able to estimate K. And compare it to what the K that I had before. So you have your K here, K damage, you compare it to the K before now. Yeah. So those are the kind of thinking that that we kind of bring into this. Yeah, I see a couple of questions. So essentially, what that means is that I can identify, I can put this guy as a candidate for pressure buildup, maybe my next campaign. No, so but it also bear in mind, it's not every time you come up with data that you say, I need to acquire this data. Where everything boils down to money, right? So yes, you've seen the issue, you've identified the data, then you now need to have that conversation about how to squeeze this into your campaign. Now, let me look at, aside using software models to understand what we can recover, what from what we have in place, what other method can we use? Asking this because not all of us have licenses to use some of the softwares. So in some cases you use analogs, right? In some cases you use analogs. For example, I'm sure in your classes you may have been taught the kind of ranges of recovery factors that you have for water drive reservoir, gas cap drive reservoir, expansion drive reservoir, right? So those numbers, they kind of give a range of recovery factors. Yeah. So from there, you can use that to also estimate what you can recover. I don't know if that makes sense. So that can give an idea. So you have range of recovery factor for water drive, range of recovery factor for gas cap drive, range of recovery factor for expansion drive. You can also use that to estimate as a starting point. The other thing you can also do, you have the material balance equation. You can also build that into an Excel file and use that as your model, right? In all these models that you see, they've just built equations into softwares. That's all that has happened. You also can translate some of those equations that you have from your material balance equation, all those Savlina and Ode and co. Use it to build it into an Excel file and use that for your work. That's also a good, I mean, you do a lot of exercise on that. So that's also a good point that you can use. So yes, you may not need to have softwares. And for me, I mean, it's good to have softwares, but for me, the main thing is your fundamentals. Once you're able to have those graphs, then you're good to go. Good evening, sir. Thank you. Please, is it possible for us to quickly have a look at the tax for this weekend? Or perhaps, Mr. Victor, whatever question we might have, we can have immediate clarification this week. Yeah,
Okay.
let me
Hello,
know.
Mr.
If,
Victor. Yeah,
yeah.
sorry to interject. Yeah, I have responded to that question. And let's just take the next question. Perhaps I could just read the questions out for you.
Okay. No worry, I'll read it. No worry.
Okay.
I want to know what role can artificial intelligence play in is there perhaps a problem encountered during engineering that you think AI could solve? Yeah, I talked about the use of surrogate models. So I think the use of surrogate models is also a very good case that you can consider. So that's one. Number two is also, I mean, the good thing about the time we are in now, there are a lot of applications that have been built into libraries that you can also use. You also can build one. That the truth is, the way the things are going now, people are looking at ways of being less dependent on the standard models like the simulators, the petrels, and all those things. So that's why the idea of these surrogate models are coming in. Because you have all these other advanced analytics or advanced algorithms that can build what those simulators are building. Therefore, people are now starting to do a lot of research in that space. There are a lot of companies that have come up based on that, right? That I know, like ResMe or something like that. So there are people that are working in that space. So back to your question. So AI can help build like these surrogate models, right? Help take away the side of data extraction and putting data together. Yeah. What else? For example, your decline curve analysis. Do I really need a standard model? Can I just build the system where the script will just pick my decline curve period for me, do the regression, automatically generate forecasts? Why do I need to use OFM, for instance, to do all those things? So those are the direction where people are thinking about. And I think you guys can also work in that space as well. So there's a whole lot of research going on in that space. You didn't mention the material balance method. Hope it's still being used in this. Yes, I did mention it. So this is it. So if you see this 0D model, I mentioned MBAL. Okay, maybe I didn't state it explicitly, but material balance models are like 0D. Yeah. So yeah, I did mention it. Yeah, thanks. It's still being used. In fact, it's probably one of the ones that is used more often than the other ones. It's as things get complicated, that's when we start going to simulators. So, but if it's just simple reservoir modeling, the starting point is always the material balance. Okay, thank you. I think that's all.
Yes. We are for time, so we can't take any further questions. Thank you very much, Mr. Victor, for the session and for this presentation. Okay, Christian, we can end the live stream now.